Now we are going to add and subtract fractions when they have different denominators. So there are two major steps. No, I lied. Three. Make a common denominator by rewriting the LCD to be the denominator. Add or subtract, and then simplify. So for the first one, they're already factored in the denominator, 3x and 10x. Comparing the 3 and the 10, the smallest number that 3 and 10 both go into would be 30. And comparing the variables, we have x and x. Since those are both to the first, we would say 30x is the LCD. Which means that comparing the first denominator to the LCD, 30x, we're missing a 10, so I have to multiply top and bottom by 10. And comparing the second denominator, 10x, to the LCD, I'm missing a 3. So I have to multiply the top and bottom by 3. Multiplying a 10 through the numerator of the first fraction gives 70x plus 10. Plus, multiplying a 3 through the second numerator gives me 15x plus, minus 12. And I can put this all over one fraction because now they have a common denominator of 30x. Okay, let's combine like terms like we did in the previous section. We would get 85x minus 2 all over 30x. Nothing cancels. Leave it alone. Part B. Start off with a common denominator. We're comparing 15x squared and 10x cubed. 15 and 10, the smallest number they both go into, is also 30. X squared and x cubed take the larger exponent, x cubed. Comparing the first denominator, 15x squared, to the LCD, we are missing 2x. Which means we have to multiply top and bottom of that fraction by 2x. Oops, 2x times. Second fraction, the denominator is 10x cubed. Comparing it to the LCD, 30x cubed, we just need 3 more. Multiply top and bottom. Distributing that 2x through the first fraction in the numerator would give 8x cubed plus 16x squared minus 3 times 3 is 9. And I can put this all over the LCD of 30x cubed. That's all she wrote. Nothing combines the numerator. There's no common factor other than 1, meaning the GCF is 1. So we leave this one alone. Part C. The denominator of the first fraction, x squared plus 8x plus 6, doesn't actually factor using integers. However, that part's not important because notice the second denominator is just a 1, which means I need to multiply top and bottom of the second fraction by x squared plus 8x plus 6 to make a common denominator. I am going to try to write this on the side because oh my gosh, this is hurting my head. Oh geez. Oh, now I have to do that all again. So we're going to multiply the 4 by that thing. Then we're going to multiply the denominator, which is technically a 1, by that thing. Oh my gosh. If you have never done this before, I suggest you try it. Sort of like when you eat something bad and you want other people to do it too. Yeah, that hurt my head. I hope you appreciate that. Now, be careful. I'm going to put this down here actually because we need the room. The new fraction's numerator will be 6x squared plus 3x plus 1 minus, because it's a subtraction, 4 times the quantity x squared plus 8x plus 6. Biggest mistake students make is they distribute the 4, but they do not distribute the negative that's with that 4. So if I were to distribute that negative 4 through, I would have negative 4x squared minus 32x minus 24. I put it up there to save some space. So now combining like terms, 6x squared minus 4x squared makes 2x squared. 3x minus 32x is minus 29x. And 1 minus 24 is negative 23. Don't forget your denominator. X squared plus 8x plus 6. So if you just have a constant like we did, it being 4, remember that's technically over 1. So same exact process as before. The LCD just happened to be the first fraction's denominator. Let's try some more. These will now have some factoring to them as well. In the first denominator, that factors as x plus 5 quantity squared. Second denominator factors as x plus 5, x minus 3. So the LCD is the product of unique factors, in our case, x plus 5, x minus 3. And now we do the powers. The x plus 5 appears twice in the first, once in the second, so we take the twice. X minus 3 appears no times in the first, but once in the second, so we just take the x minus 3. So comparing the denominator of the first fraction to the LCD, what's missing? Notice we need an x minus 3, so I have to multiply top and bottom by x minus 3. Second fraction's denominator, x plus 5, x minus 3. Compare that to the LCD. What's missing? We need one more x plus 5. Okay, so the new fraction, the numerator is 3x plus 7, x minus 3, plus goes in between them, 7x plus 2, x plus 5, all over the LCD, x plus 5 quantity squared, x minus 3. Now in these problems, it's common to just FOIL out the numerator and leave the denominator factored. Doing so, we would have a generous, what would that be? 3x squared minus 9x plus 7x minus 21. Plus, FOILing out the second one gives us 7x squared plus 35x plus 2x plus 10 all over, and leave that all factored. Okay, combine like terms like you've never done that before. 3x squared plus 7x squared makes 10x squared. Minus 9x plus 7x is negative 2x, plus 35x plus 2x just makes 35x. And negative 21 minus 10 is negative 11. All over the good stuff. Now that numerator, I don't think that factors. Let me play with that in my head. I think we're good. Yeah, we're good. So we leave that alone. If it were to factor and cancel, we'd have to factor it and cancel, but it does not. So we'll just pretend, we'll just sweep it under the rug there. Now, due to space, I'm going to have to shrink down the stuff in purple there. So if you need to, pause the video. I'm assuming you paused the video. Proud of you. So let me select all this. I love this software. Shrinky dink. And then I'll move that over there. Look how clean that is. Don't you wish you could do that with, like, you know, stuff in your house? Instead of throwing it away, you just shrink it down and put it like in a box somewhere. That'd be great. For part E, let's factor that. The denominator in the first fraction factors as 2x plus 5, x minus 3. The second one factors as 2x plus 5, x plus 4. So the LCD is the product of unique factors. we would need a 2x plus 5, an x minus 3, and an x plus 4. They each appear only one time. Comparing the first fraction's denominator to the LCD, we are missing x plus 4. So upstairs and down, write the x plus 4. Oh, that looks like an x minus 9. 4. All right, that's good. I fixed it. And downstairs 4. It did it again. Stop doing that. Bad software. All right, the second one, comparing the denominators in factored form to the LCD, we are missing an x minus 3. So multiply top and bottom by x minus 3. Ooh, squishy. Okay, so cleaning this up, I'm going to use black. Be careful, we're going to have one fraction now. The reason I'm saying be careful is because we have a subtraction, not an addition. Addition is much easier. And if done correctly, the denominator is always the LCD. That's a 4 there. I'm having problems with my 4s today. Foiling. Upstairs, we get x squared minus 9x plus 4x minus 36. Minus, notice the use of parentheses, x squared minus 3x minus 2x plus 6. All over that LCD. Now, if you are comfortable with these, then you can skip some steps here. For instance, I wrote all 4 terms for the foiling. If you want to combine the inners and outers, if possible, please do so. Also, is I'm going to write off to the side due to space constrictions, is I'm going to distribute this negative through. So minus x squared plus, well, let's clean this up. Negative 3x minus 2x is negative 5x. So combined would be, I'm sorry, yeah, I said that right. Negative 3x minus 2x is negative 5x. So distributing the negative through is now positive 5x. And then instead of plus 6, distributing the negative through, we got minus 6. Yay! So x squared minus x squared, what happens to those? Cancel. Negative 9x plus 4x is technically negative 5x. Negative 5x plus 5x, what happens to that? Cancels, that whole thing cancels. And negative 36 minus 6, that does not cancel. We get negative 42. And the denominator is the LCD. And after we write this problem is done because nothing else cancels.